Hello and welcome back to Minute Micro Macro. We're looking at the 2023 Microeconomics paper, Set 1. Our first free response question. KB is a profit maximizing monopoly that produces new patented electronic device. RKB is earning positive economic profit. Draw a correctly labeled graph for RKB and show each of the following: the profit maximizing quantity, the profit maximizing price, the average total cost curve consistent with positive economic profit, the area representing the deadweight loss shaded completely. Okay, let's have a go at that. I'm going to draw my axes. On my y-axis, I have my costs, my revenues, and my prices. On my x-axis, I have my quantity or my output, and label that Q, and then cost/price. I'm going to draw a reasonably steep average revenue because we know they're a monopoly, and label that AR. I always draw my average revenue in red because I like to associate it with demand. Then I'm going to use my orange, and I'm going to draw a marginal revenue curve that's twice as steep as average revenue in orange, cutting through the midpoint between the origin and where average revenue would cut through the quantity axes. My average total cost is a U shape, ATC, and I want its minimum point, just for the sake of a neat, easy to read diagram, between the marginal revenue and the average revenue. That's not a rule, that one, that's just my personal preference to keep neat diagrams when we haven't got a position specified for my average total cost. Then I'm going to do my marginal cost in blue, cutting through my average total cost at its minimum point, and I like to color code that in blue so I associate it with supply. They want the profit maximizing quantity labeled QM. Well, we know that profit maximizing firms set their quantity based on where marginal cost equals marginal revenue, MC equals MR, at this point here. This means here I'm going to set my output at Q. Then, part II, they want the profit maximizing price labeled PM. I go up from my quantity until I hit my average revenue, and then I read across. This is the price that a profit maximizing monopoly would set. 3. The average total cost curve consistent with RKB earning positive economic profit. I have already drawn that. And then the area representing the dead weight loss shaded completely. Well, if we were trying to be allocatively efficient, we would be producing where the price is equal to the marginal cost. Well, if I want my price to be equal to the marginal cost, it needs to be where my average revenue is equal to my marginal cost, which is this point here. Everything below that point is producing below the allocatively efficient level. And so my dead weight loss is all of this triangle. So it's from the point where MC equals MR, up to the point where MC equals AR, up to the average revenue that's directly above the quantity. B. The government wants RKB to produce the allocatively efficient quantity. Would the government impose a binding price ceiling, a binding price floor, a per unit tax, or a lump sum tax? We want to bring the price down so that P equals MC if I'm trying to be allocatively efficient. If we want P equals MC, we're going to set a price ceiling below the current price. And so part B, the answer is price ceiling. C. Suppose the government does not impose the policy you identified in part B. Consumers now become aware of research that confirms the use of this new device's harm on users' vision. Given widespread consumer awareness of this research, what will happen to RKB's profit maximizing quantity in the short run? Explain. So, if we're expecting there to be a fall in demand, then we know that for the firm, my average revenue will fall and my marginal revenue will fall. If anything happens to marginal revenue or marginal cost, my profit maximizing condition is going to change. Now, if my marginal revenue fell, it would intersect MC at a lower point on the quantity axes. So if we see a fall in demand, there'll be a fall in average revenue, a fall in marginal revenue. That means there'll be a new profit maximizing condition and point, and we're going to see a new lower quantity. D, assume that RKB hires workers in a perfectly competitive labour market. Draw a correctly labelled graph for the labour market showing the equilibrium wage and quantity of labour labelled WE and quantity QE respectively. I'm going to draw my axes. I've got my quantity of labour and the price you pay labour, which we know is wage. Then we have supply of labour. Supply of labour, all the people who are willing and able to work at different wages. Supply goes to the sky, and I'm going to put a little L to remind myself it's the supply of labour. The demand for labour is all the firms wanting to hire workers at all the different wage points. Just like a supply and demand diagram, we read off the equilibrium. I'm going to call that QE, the equilibrium quantity, and WE for the wage equilibrium. II. Suppose immigration increases the number of workers in the labour market. On your graph, show the new equilibrium wage and quantity, and we're now labelling it W2 and Q2 respectively. If we're going to see an increase in immigration, we're going to see an increase in the supply of labour. This is shown as a shift to the right. So let's draw that onto the graph. I'm going to label that S2, and we can see that will form a new equilibrium. We're going to have an increase in the quantity of labour that is hired now. I'm going to call that Q2, as they asked me to. And we're seeing a fall in the wage to W2. So we're going to see a shift right. We're going to see an increase in the quantity of labour employed, and we're going to see a fall in the equilibrium wage. III. RKB use an optimal combination of capital and labour in its production process. The firm rents capital at $500 per unit, and the last unit of capital rented had a marginal product of 2,500 units. If the marginal product of the last unit of labour this time is 1,000 units, calculate the wage rate. I'm going to break down the key pieces of information. We know that the marginal cost of capital is equal to 500. The marginal physical product of capital is 2,500. We know the marginal cost of labour is the wage, and that's what we're working out. And we know the marginal physical product of labour is 1,000. If we're trying to decide how much of each we should use as a firm, because we can substitute labour for capital and capital for labour, we're going to use the equation MPP of capital divided by MC of capital has to equal the MPP of labour divided by the MC of labour. So I'm going to substitute those numbers in. My MPP of capital is 2,500. My marginal cost of capital was 500. My MPP of labour was 1,000. And I don't know my marginal cost of labour. That's what I'm trying to work out. I know straight away that 2,500 divided by 500 is 5. That is equal to 1,000 divided by my marginal cost. If I multiply both sides by marginal cost and divide both sides by 5, I'll have marginal cost is equal to 1,000 divided by 5, and that is $200. Question 2, we're looking at comparative advantage now. The graph shows the production possibility curves for Northland and Southland. You can see here, Southland can either make 100 bushels of wheat while making no cloth, or they can make 50 yards of cloth while making no wheat, whereas Northland can produce 100 bushels of wheat if they make no cloth, or they can produce 300 yards of cloth if they produce no wheat. Which country has a comparative advantage in producing wheat? Well, before I just jump to answering that question the quick way by looking at the graph, I always like to write out my grids So if I turn that into a table, I know that Northland can produce 100 bushels of wheat, or they could make 300 yards of cloth, and Southland can produce 100 bushels of wheat, or they can produce 50 yards of cloth. Now I like to always write my opportunity cost grid. So my opportunity cost is my next best alternative foregone. Actually, to be precise, it's the value of the next best alternative foregone. So if I'm Northland and I want to produce wheat, I would have to give up making cloth. So I'd have to give up 300 yards of cloth for every 100 bushels of wheat. So my opportunity cost would be 3. If Northland wanted to produce cloth, they would have to give up making 100 bushels of wheat for every 300 yards of cloth. And so the opportunity cost of producing cloth is 1/3 of a bushel of wheat. Now, Southland. If Southland wants to produce wheat, they need to give up 50 yards of cloth for every 100 bushels of wheat. And that equals 1/2. If Southland wants to produce cloth, they have to give up 100 bushels of wheat for every 50 yards of cloth they want to produce. 100 divided by 50 is equal to 2. Then each country should produce what they had the smallest opportunity cost in. So to produce wheat, North has an opportunity cost of 3 and Southland has an opportunity cost of 1/2. So Southland should produce wheat. And we're looking at cloth. Northland has an opportunity cost of 1/3, whereas Southland has an opportunity cost of 2. So Northland should be the ones to produce cloth. I like to write this all out when I have a question like this, so that I can then get straight back to the question and answer them without getting confused. Which country has a comparative advantage in producing wheat? The country with a comparative advantage in producing wheat is Southland. The explanation for that would be that they have the smallest opportunity cost to produce wheat, because 1/2 is smaller than 3. B, identify a specific number of yards of cloth that could be traded for 10 bushels of wheat. That would be mutually beneficial to both Northland and Southland. We've got this grid. We can see that Northland are producing cloth, so they're selling cloth, buying wheat. So they're selling cloth and buying wheat. If we are trading 10 bushels of wheat, Northland could produce their own wheat. They would buy it if it's cheaper to buy it for them than to make it. Well, if they wanted to make 10 bushels of wheat, they would have to give up 30 items of cloth to make 10 bushels of wheat. So we need the number to be less than 30 for it to be worth Northland buying the wheat. Go to the south. The south are selling wheat and they are buying cloth. If they were going to reduce their production of wheat by 10 bushels, they could make 5 yards of their own cloth. So 5 is the key number. Any number between 5 and 30 is correct. So I might say 25 yards is my suggestion. Any number between the two would mean it's a mutually beneficial trade for both countries. Southland's maximum possible output of wheat falls from 100 bushels to 75 bushels. Assuming no other changes, will Southland have a comparative advantage in producing cloth? Use numbers to explain. We're going to change some of the numbers on here. We are seeing Southland output of wheat falls. So Southland wheat is going to fall 75. So Southland's opportunity cost is going to change. If they wanted to produce wheat, they would have to give up 50 yards of cloth for every 75 bushels of wheat. That is going to be equal to 2/3. And if they wanted to produce cloth, they'd have to give up 75 bushels of wheat every 50 yards of cloth. That is 1.5. So let's check which country has the comparative advantage still. Let's see. We want the smallest opportunity cost, 3 or 2/3. Okay, yeah. They still have the advantage in producing wheat, and 1/3 is still smaller than 1.5. So North still has the smaller opportunity cost. So North still have the comparative advantage in cloth. They wanted to know, will Southland have a comparative advantage in producing cloth? No, they do not. No, 1/3 is still less than 1.5. So Northland still has a comparative advantage in producing cloth. D. Turnips are produced in a perfectly competitive market in Algeria, a third country, which does not engage in international trade. Runoff from turnip fields pollutes Algeria's rivers, hurting its residents. Does the turnip market equilibrium result in an efficient allocation of resources? Explain using marginal analysis. We clearly have a cost to a third party, and that is a negative externality of production. Let's write a chain of reasoning. The runoff clearly pollutes, and this is a negative externality of production. We need to answer this with marginal analysis. If we have negative externalities, specifically of production, we know that the marginal social cost is greater than the marginal private cost. We know that the free market will produce where marginal private cost is equal to marginal private benefit. The socially optimal level will be where the marginal social cost is equal to the marginal social benefit. The free market will produce at a quantity above the socially optimal level. In an effort to reduce pollution, Algeria's government imposes lump sum tax on turnip production. What will be the impact on the turnip market equilibrium price and quantity in the short run? The key bit of information is that this tax is a lump sum tax. A lump sum tax is a fixed cost to firms. If we're talking about a fixed cost, we're talking about a change in average cost, but not a change in marginal cost. So it's going to increase our average cost curve. There's going to be no change in marginal cost. Remember, if we're not changing marginal cost or marginal revenue, there's no change in the profit maximizing quantity, and so there's going to be no change in output. So no change in equals MR, so no change in output or quantity, and no change in price. Question 3. The graph provided shows the demand, marginal revenue, average total cost, average variable cost, and marginal cost curves for Hansel Hangouts, a typical profit maximizing firm in a perfectly competitive market producing good X. Calculate Hansel Hangouts' total fixed cost. Show your working. First thing I'm going to do is get a larger graph and color code it. I know that my demand and my average revenue are red, and it's perfectly competitive, so they're horizontal. I like to draw my marginal revenue in orange, and because average revenue is horizontal, marginal revenue is the same. My marginal cost is always in blue, my average total cost is in green, and they've included my average variable cost. So the distance between my average variable cost and my average total cost is my average fixed cost. Of course, my fixed cost isn't changing, so as I increase the quantity, I'm dividing by a bigger number each time when I'm finding the average, and so the gap is getting smaller between my average variable cost and my average total cost. Back to the question. They asked us to calculate their total fixed costs. We know they're profit maximizing, so they're going to be producing at the point where MC equals MR. MC and MR intersect here, and so they're going to be producing 6 units. Let's see everything we know about the level of production at 6 units. I know that their average total cost is $21. I know that their average variable cost is $9, and that is actually enough for me to work out the answer to that question. I'll show you how. So like I said, my quantity was 6, my average total cost is 21, and my average variable cost is 9. Well, I know that my total cost is my average total cost multiplied by 6. So 21 times by 6, that's 126. I know that my variable cost is my average variable cost multiplied by 6. So that's going to be 9 times by 6, and that is 54. We already said that my fixed cost is the difference between my variable cost and my total cost. So if I do 126 minus 54, it is going to be a fixed cost of $72. Part B, identify the price Hansel Hangout's profit maximizing quantity of good X. We have already worked that out. The price is going to be $14 and the quantity is going to be 6 units. Easy. 3, calculate Hansel Hangout's economic profit at the quantity identified in Part B. So they want the profit at the Part B quantity. So at 6 units, what is the profit they're going to make? So at 6 units, the total cost is 21. And at 6 units, my average total cost is 21. So it's costing me $21 times by 6 to produce this good. And it's making $14 for each good. So the difference multiplied by the quantity is usually the profit. However, you might have spotted something that's different about this graph. The cost is above the revenue at our output. And so they're actually making a loss. But the question very specifically asked for the profit. So we're going to have a negative profit. A cost of $21 minus my revenue of $14. I'm going to find the difference and then multiply that by 6 because that's how many I'm making. And that gives me 42 of loss. But they asked for the profit. So we're going to say a negative $42 profit. Part D, as the market for good X adjusts to the long run equilibrium, what will happen to the price of good X? So they want to know what's happening to the price and they want us to explain. Well, our firm's making a loss. It's reasonable to think that other firms are making a loss. And so loss-making firms leave the market in the long run, which is what they asked us. If firms are leaving the market, that means the supply will shift left. If supply shifted left, we can draw ourselves a very quick sketch. Price, quantity, supply to the sky, demand down. If supply shifted left, we can see that the price would increase. And so the price of good X will increase. Part E, assume the cross price elasticity, so the XED, of demand between good X and good C is positive. Given the change in the long run price of good X that we have established in Part D, will the quantity of good C increase, decrease, or remain the same? Explain. So we'll do a quick chain of reasoning to run through this one. We know that if XED is positive, then we are dealing with a substitute good. So C is a substitute for X. Now, we know that the quantity of good X is going to decrease. We saw that on that little sketch that we did a few seconds ago, and the price is also increasing of good X. So with a downward sloping demand curve, we know that if price increases, quantity demand is going to decrease. If the quantity of good X being demanded is decreasing, then consumers are going to switch to a substitute, an alternative good. In this case, that is going to be good C. If they're switching to good C, we can imagine that the quantity of good C is going to increase. So the quantity demanded of good C will increase. Well done, you made it to the end of this paper. See you next time.